2.2 greatest common factor. I can find the greatest common factor.
Sweet, thank you, Mason. Mason, are you confident that you can find greatest common factor after that lesson today?
Yes.
Good. Now, you guys, I put GCF. Do you understand that GCF is just the short way of saying greatest common factor, right?
Yes.
Okay, cool. So we can use GCF, and you will actually see that in a lot of your math assignments, maybe even on some of your math tests. It'll say GCF. We need to understand that that means greatest common factor. Okay, so the definition of a greatest common factor: the biggest number that two or more numbers have in common. The biggest number or the biggest factor that two or more numbers have in common. Okay? Now, the key to this whole thing is the greatest common factor can never be as big as what? Someone tell me, raise your hand. The greatest common factor, I should see all hands. We've talked about this 1,000 times. I see one. The greatest common factor can never be as big as what? Thank you, that's much better. The greatest common factor can never be as big as what, Eva? No. The greatest common factor, it's on the board, you guys, even if you forgot it, can never be as big as what, Ariana? It can never be as big as the smallest number. It's our cheat sheet. The greatest common factor can never be as big as the smallest number. But remember, can factors be bigger than the given number? No. Factors can't be as big as a given number. Follow me over to the cheat bowl here. You guys asked me to write this down on Wednesday. Factors are the same or less than the number we give you, or I give you, or the work assignment gives you, or the test gives you, right? Okay. So the greatest common factor can't be any bigger than the smallest one. And let's talk about what that looks like here. So you all did this. We have 10 and 30. We said the greatest common factor of 10 and 30 was what? 10. We found all the factors of 10 using our factor pairs, using our T-chart. We found all the factors of 30 using our factor pairs and T-chart. We circled the ones that were in common. Yes, no?
Yes.
So we circled all the ones in common, and if they weren't in common, we crossed them off. What is the biggest number that 10 and 30 have in common?
10.
That's our answer, right? Okay. 11 is not an option, is it?
No.
Could 11 ever be a factor of 10?
No.
It could never be a factor of 10 because it's bigger than 10. A number that is bigger than another can't go into it. Okay? So when we slide down to our next example here, we had 36 and 81. And there's a lot of factors for 36 and 81. What would help you? If you knew your what, this would be a lot easier to complete. Especially my second group who did these notes. If you knew what, you could find factors more easily. What do you need to know, Cece?
Your multiplication factor.
You need to know your multiplication facts. Okay, I'm not going to say names, but that first group who did these notes, you guys were way faster at this than the second group. And the reason you're way faster at it is because you knew your multiplication facts better. Okay? So we found all the factors of 36. We found all the factors of 81. We circled the ones that they had in common. Yes, no?
Yes.
And which one was the largest number, Jordan, that they had in common? 9. Got it? Okay, so we put down 9, we boxed it. What is the largest possible answer? Before we started solving this problem, what was the largest possible answer that this could be? Everybody.
36.
36. Was it 36?
No.
It was 9, right?
Yes.
Okay. And then the last one, we're not going to spend a whole lot of time talking about this one. I just gave you 3 of them. Now they have to have something in common on all 3 of them. It can't be 2 of the 3, it's got to be all 3 of them. So we had a 1, a 2, and a 4. What was the biggest number that they all had in common?
4.
4. So you're making T-charts, you're circling the ones that are in common, you're crossing off the ones that are not. Questions?